Okay, everybody, I think we are ready to get started. So good morning. Thanks, everyone, for joining us. My name is Matt Radishonsky. I'm a member of the Mentor Graphics embedded software team. Joining us today will be a handful of industry experts to discuss smart energy market trends. We're very excited about this event. We put a lot of effort into it, and we're excited about the group who's joining us today. We'd like this event to be as interactive as possible, so please feel free to use the commenting section that's just below the live video that you see playing there, and we'll answer your questions in our video feed here real time as we go through our presentation and cover the topics that we're going to talk about. We've also got some allotted Q&A time at the end of the presentation, so any questions you have at the end we can answer then too. So we've got a panel today, and moderating our panel will be Colin Walls. Colin is a technical marketing manager for Mentor Graphics embedded software. He's got 25 years experience in the electronics industry, largely dedicated to the embedded software sector. Many of you may have seen him at conferences or at industry events, and Colin's got some books and some technical articles out there too. So he's a member of our marketing team. He's based in the UK. And Colin, I'll pass it over to you, and you can do an introduction of our panel members and get the panel questions started.
Okay, thanks, Matt. Thanks for the big build-up. Yeah, I'm Colin Walls, and I'm going to be chairing the session today. And what I'm going to do to start out with is just show a few slides and talk about what we're going to do and introduce the other members of the team. So let's just start the slides. Here we go. So today's session is all about smart energy and the market trends, and it's going to be the format is going to be a panel discussion. So we have some questions which have been sent in advance, which we're going to pose first of all, but anybody who's listening is welcome to type in more questions, and we'll take as many of those as we can towards the end. So the team we have today, you have listed in front of you from some key companies in the industry. So we have Michael Polk from Itron, Harry Forbes from ARC, Mike Dow from Freescale, and Andrew Caples, my colleague from Mentor Graphics. So you have my contact details here on the screen, but it's not really about me, it's really about what the rest of the team, the experts in this field, have to say. So I'm going to hand over to each of them in turn and ask them just to say a few words about where they fit into this business. First, we have Michael Polk. Michael, let's hear from you.
Yeah, so this is Michael Polk. I'm from Itron, the division of Itron Cellular Solutions, and we retrofit residential and commercial meters with cellular modules that allow them to return back to a head-end system at the utility room and reporting usage information and statistics on what's going on with power consumption at that location.
Okay, thank you, Michael. Next up, we have Harry Forbes from ARC Advisory Group. Harry.
Thank you, Colin. I'm Harry Forbes, based in Boston. I'm an analyst with ARC Advisory Group. ARC Advisory Group is a market research advisory service and consulting firm. Our focus is more on the industrial automation and manufacturing marketplace, but they're very concerned with energy too. And so energy is a worldwide concern, but we have more expertise in industrial and commercial.
Okay, thank you, Harry. And Mike Dow, who's been having some communications difficulties. Let's see if he can speak with us. Mike.
Hi, my name is Mike Dow. I work in Austin, Texas. Freescale has a 50-year history. You may remember us primarily as Motorola. We were Motorola until roughly 2000, early 2000s when we were spun off from Motorola. And
Mike, you seem to be breaking up a little, so I'm going to move on for the moment. Let's hope your connection improves as the session proceeds. So we'll look forward to your contribution, I hope. Last and by no means least, Andrew Caples, my colleague down in San Diego, I believe. Andrew.
Yes, hi, my name is Andrew Caples. I'm the Senior Product Marketing Manager for the Nucleus Real-Time Operating System. Nucleus is a widely deployed operating system in over 3 billion devices worldwide. Our interest, we've done a lot of work with companies interested in smart energy and smart grid technologies, and consequently we've enhanced Nucleus with protocols to facilitate smart grid type communications. So.
Okay, thank you, Andrew. So, talking about smart energy, first of all, I'm not going to go into lots of detail at this point. Broadly, just to set the scene, smart energy is really a bit of a catch-all term which covers a lot of different technology areas. So we're looking at home automation in general, smart appliances, networking around the home, and connections to utilities, so smart meters and so forth. So that's really the whole area which is encompassed by the term smart energy, just to put it in context. Can't resist just a very short sales pitch. The intention of this session as a whole is to look at the technology, but as Andrew already mentioned, our Nucleus RTOS is particularly well suited to applications in this space, and we have support for all the right protocols. I'm not going to go into lots of detail, plenty of information on our website, and the diagram in front gives you a very quick summary of what we're all about. But let's proceed with the panel session itself and some questions. And we'll start out. I have a series of questions lined up ready to go. And we'll first start out with one which is very simple, just setting the scene. And that is the question, what are the smart energy trends that you're seeing? Now I'm going to start out by asking Andrew Caples if he can give us some input from Mentorgraphic's perspective here. Sure,
no, I appreciate that, Colin. So essentially when I think of the smart energy trends, I kind of back up and look at what's happening over the last couple of decades. It's a well-known fact, peak demand has exceeded the growth in transmission by 20 to 25%. I mean, this is not sustainable. There's predicted rolling blackouts that are going to take place, and this is in North America. Power outages alone cost a significant amount of money, hundreds of billions of dollars a year. So in the way this is addressed, peak demand is through what is deemed peaker plants, which are the most inefficient and expensive plants to operate, emitting lots of greenhouse gases, buying fuel at spot market prices. So just the costs looking forward to enhance the grid and the infrastructure to address the peak demand is estimated to be over $1 trillion the next 10 or 20 years. So from a trending perspective, it just doesn't seem like there's a good supply side solution, and therefore I think smart energy comes into play to make the grids more efficient, more reliable, to empower consumers to control the amount of energy they consume, especially during peak demands or peak periods, in order to smooth out the demand when the grid is operating at its most inefficient or inefficient state. So that's the big trend I see, Colin.
Okay, thank you, Andrew. Mike Dowell, do you have some input on this area of what are the trends that you're seeing in smart energy?
Let me look. Colin, can you?
Not getting a very clear reception from Mike Dowell here.
Yeah, I apologize for that. But if you guys can hear me, the trend that I'm seeing right now is the move away from the concept of just looking at home energy management and looking at smart home from a holistic standpoint, including security, lighting control, medical. Is anybody hearing any of this?
Yeah,
Mike, I'm hearing you okay?
We can hear you, Mike.
Okay, good. So that's the biggest trend I see, is that home energy management by itself is not really taken off very well. But I think that the combination of these various vertical markets into a single device that can management, I think will actually make this smart energy and home management, energy management take off a little bit faster.
Okay, thank you, Mike. We seem to be having some interesting technical difficulties this morning, but we'll get on with it. Next topic is broadening out slightly. What are the drivers to the adoption of the smart energy technology? I'm thinking here particularly of, say, regional drivers. Harry, I think you probably have some input on this area. I'm not hearing from Harry. No, Harry was with us a little while ago. Okay. Well, I'm going to skip forward slightly and consider some other issues, and if Harry comes back with us shortly, we can readdress this. Let's have another look at an area which I think is very important with all areas of embedded software, and that's the matter of standards. Standards-based software is what everybody looks at nowadays. And what are the standards that are driving the adoption of the smart energy technology? And I think, Andrew, this is something, again, which I know is close to your heart. Maybe you can give us some insights here.
Yeah, just some thoughts that come to my mind. I mean, when you think about standards, and first off, when you think about a smart grid, any new application can essentially make the grid a smart grid, right? Adding some more monitoring capability, control capability. So I kind of think of this as maybe a smarter grid. And when I think of standards, I'm looking at it from not so much the application perspective, but more the communication perspective. Maybe an architecture that's a deliberate architecture that's IP based and supports various applications, hardware, software. They're easily integrated, essentially, to provide the integration of the smart grid with a communication network. For the monitoring and controlling of the generation, the transmission, the distribution, and the consumption. And of course, the overall goal is to decrease costs and decrease capital expenditures, lower carbon emissions, and integrate renewables. And so those are the trends, I think. Historically, you've seen utility companies own generation, transmission, distribution, all the way to the meter. And now with standards-based approaches, you can have best-of-class applications fulfill some of those different silos. You're starting to see, SEP 2.0 gain acceptance. I mean, you've got prototypes that are being deployed in various regions, in the country here in North America, to really shake out and test those standards and verify the benefits. So. That would be my input on the subject, Colin.
Okay, thank you, Andrew. So we continue to have our technical challenges here. Harry, we seem to have got you back online now, I think.
Yes, I'm here. If you can hear me, can you hear me, Colin?
Okay, let's backtrack slightly. We had a question when you disappeared a little while ago.
Sorry about that.
That was what are the drivers to the adoption of smart energy technology? I'm particularly interested here in regional drivers in different parts of the world. What are you seeing?
Well, the reason, Colin, that regional drivers are important is because, especially for electricity, it doesn't travel from continent to continent. So region or continent has to make its own supply. And really, I'd look at a few variables. Obviously, an important one is price, which varies widely. Availability of electric energy varies widely. And then there's obvious implications for what people's policy is, and then the attitude of consumers. And these vary an awful lot from place to place. In general, in North America, we have low prices and high reasonable availability. What really drives the consumer to this smart energy would be things that drive consumers to consumer products, like consumer choice, empowerment. Commercial is more challenging, and industrial is more challenging because of the lower prices, believe it or not, that we enjoy in North America, especially compared to other regions. If you go into Europe, the prices are, in general, much higher. So that's a driver of sorts. And also, I would say there's a more conscious conservation or green attitude among consumers in Europe. So it's a little different situation. When you go into Asia, the prices may well be very high, but in many parts, especially the developing economies, availability is a problem. If you've ever experienced the daily or multi-daily blackouts in parts of Asia where availability is a problem. And so a lot of what drives smart energy there is going to be policy and allocation of resources. The loads, electric loads, have been growing at around 8% plus in China historically for the last 10 or 15 years. And their concern, obviously having much more of a command economy than we do, is that as more and more of their population moves out of poverty into middle-class life and begins consuming energy, how can they sustain that economic development, which is a high priority for them, without having a huge infrastructure and huge pollution problems. So they're really looking at smart energy as an allocation problem to make sure that they're using energy for the most beneficial needs at all times.
Okay, thank you, Harry. Going on from that, and maybe it's an area you feel you cover, but we can give it a go. What are the challenges to the adoption of smart energy technology? Is there anything in addition to what you've said about the drivers, the challenges, drivers, much the same thing, really?
Well, let's take a look, say, at North America, and the way that things work in North America is we have a very fragmented utility market. We have 50 plus regulators of the electric utility market. We have some regulation at the federal level, but most of the power for regulation is at the state level. And then the utilities are fragmented as well. There's really a few hundred investor-owned utilities and thousands of smaller municipal utilities and cooperatives. So the challenge is that if you're a product company and you're facing that, there is not a consumer market. You have a kind of an industrial market that's highly regulated. The other problem is that from a utility standpoint, if you're sitting in the shoes of a utility company, they have an obligation, if you will, to serve the public. So that part of their regulatory charter is they have to serve the whole population of the public, unlike a consumer products company that can segment particular prime or super prime customers for a particular product. A utility has an obligation to serve all. So if they create a policy or an incentive, they have to be able to apply it across the whole customer base, prime, subprime, everybody. That's generally the way policy will work out. And the other point is it can be relatively slow. Without making any jokes about it, there are plenty of good jokes about how quickly utilities will adopt technology. So those are really barriers that are separated quite a bit from the consumer electronics kind of space. Happily, to some degree, in the commercial and industrial world, while utilities segment those kind of customers, they can be treated a little bit differently because they're kind of voluntary categories or segments for the utility. So no politicians are going to be crying tears about utilities being unfair to heavy industry or being unfair to commercial entities. Whereas if a utility appears to be unfair by its policy or programs to poor people, that's going to be difficult to justify.
Okay, thank you, Harry. Let's move around now back to the area of standards that we were talking about earlier. And Andrew touched on the smart energy profile, and it does seem to be a leading protocol in this area. What are you seeing here, Mike Dow?
Yeah, the interesting thing I'm seeing with Smart Energy 2.0 is that it was one of the first profiles that was designed to write over several different PHYs, like Wi-Fi, home plug green PHY, and 15.4 radios, which was wonderful. But there's been a little bit of a stall in deployment because there's a lot of Smart Energy 1.x out in the field, and the utilities are struggling with how to upgrade those devices. They're also struggling with the rapid turnover of the protocols. So again, what I think is going to happen is that Smart Energy 2.0 is going to merge with home automation profile at some point. This has already happened in Europe, driven by Energy at Home, which is a European appliance manufacturer alliance, where you basically combine a lot of the profiles from smart energy into home automation. And so in HA 1.2, you have that combination. So I think there's going to be more of that consolidation of these profiles.
And I think we have lost Mike down for a minute. Yeah, Mike, you were breaking up then, but let's move on a little. I'm looking further at SEP standardization. Andrew, do you see the standardization for renewable energy applications, like home generation via solar, wind power, and so forth? Do you see the SEP standardization here?
Well, I mean, we certainly see, as an example, Tier 1 white goods manufacturers, very interested in SEP 2.0 and looking to integrate SEP 2.0 technologies into their appliances. Very interested in protocols, that are more associated with the Internet of Things, but also zero configuration technologies. So, as part of a home area network, devices can be integrated into the network easily and self-configurable. We're seeing interest in security, like TLS and AES. So, and these are all components of, SEP 2.0. So from a home area network perspective, certainly we see what appears to be an embracement by some manufacturers, and we expect the adoption to increase. And I think part of it is driven by what's happening at a regional level. I mean, if you look at like the Pacific Northwest as an example, where they have a very major smart grid initiative going on, I believe it's somewhere near 60,000 participants are participating in this as a way to integrate renewables, so looking at the edge of the grid, but also empowering consumers to make informed choices when it comes to energy consumption. So, I mean, we see it across the spectrum, from the manufacturers all the way through the actual energy providers.
Okay, thank you, Andrew. Continuing on with connectivity in general, what specific connectivity standards are being embraced? And this is something which I think several of you may have something to say here. Mike Dowell, do you have some input here?
I'm sorry, I was messing with my controls. Can you guys hear me?
Yes, I can hear you fine.
Okay, what was the question?
So what specific connectivity standards are being embraced in the smart energy world from your perspective?
Well, there's two areas. There's the home area network and the neighborhood area network. I think there's some interesting things going on in the neighborhood area network where we finally have a narrowband frequency hopper specification from IEEE, that's 802.15.4G. There's some work within Zigbee and another alliance called the WeSun Alliance to actually standardize the communication protocols above the PHY and MAC layer. And that's all very interesting because at some point, if that standardizes up to the network layer, you will be actually able to pass messages across different meter manufacturers' networks. And that opens up the possibility of doing more with those types of networks, like street light control and some other things, which I think some of the meter companies are looking into.
Okay, thank you. Harry, do you have anything on this topic?
Well, we struggled with those kind of things in industrial applications quite a bit. I think one of the things that is a challenge there is the kind of data rates that are available in 15.4 networks, and the applications that the smart energy applications have to kind of share the available capacity with the, if you will, critical applications on metering networks. And from a utility standpoint, meter data collection is fairly critical, and it isn't critical because it takes a lot of bandwidth. It's critical because it's the cash register, if you will. It's very sensitive information that has to be correct. So that's a challenge in that area for standards, but they definitely are making a lot of progress. We've seen that in industrial applications of 15.4 as well.
Okay, Michael Polk, from the Itron perspective, what do you see in terms of connectivity standards?
Well, so first of all, since our module has a cellular modem in it, we have a different set of standards than some of the other guys are talking about. Although we do support hand and other wireless interfaces to energy or smart energy type devices, but our chip manufacturers basically certify the lower level CMA and GSM type stuff, but from an application level, we have a lot of things that we have to do for the carrier. So, for example, a certain carrier will have a way they want the meter to behave, or the way they want the modem to provision, or what the back off and retry is if we lose the network and stuff like that. So we have we go up one level for how we have to behave properly on the cellular network, because we're using the same cellular network that people are using with their cell phones. So if we have 10 million meters call in on the same tower at the same time, then we possibly could disable 911, for example.
Okay, thank you. I'm going to move on forward a little now, and we'll talk about smart meters and utility companies and so forth. We know about smart meters, we hear about them being installed. Is that the primary means of connection back to the utility company? And if not, what would be the primary connection? Mike Dow, you may have something to say on this?
Yes, I think, I've been in this business with Freescale for about 3 years, and when I first started, there was a lot of discussion about demand response, connecting directly from the meter to the appliances. I think in general, I'm seeing it either through consumer or the consumer and saving energy, because back off the utilities for actually commanding appliances directly. So there's a green button initiative which the government pushed for, which was to standardize the way that meter data is presented to the customer, and it also, I think more importantly, offered a way to standardize the data for third-party applications. And what I see is a shift from what I call demand response, which is kind of the stick approach, to the carrot approach, where you do incentives, where you basically just ask the consumer to save energy during peak times, and they respond as they want to for various reasons. And those various reasons within these third-party occasions can be like a rewards program where
I think you're breaking up, Mike, and I'm going to move on and ask Michael Polk if he has some input on this area. Michael, do you have any comments on the connection back to the utility company and how that's gonna fit?
Yeah, well, today we use Sailor. And going forward, it's hard to tell. There's so many different new technologies coming out, and with the adaption of home area networks and things, it's the bandwidth is having to be increased to support all the information to be presented or to be collected. So I really don't know, or I don't think anybody really knows which direction it's going to go in. I think it's going to be driven by the market.
That's always a good answer to this kind of question, I guess. Harry, do you have any input from ARC Advisory's perspective?
Yeah, if you want a little bit more controversial, I guess I would say I would argue that the meter, and especially connecting the meter with 15.4, is not the way that most homes are going to be integrated with future smart energy applications. There is certainly a problem in terms of where the meters are located. Someone mentioned before in this webcast the issues that arise with updating software, embedded software within meters, that's utilities perceive that as a risk. And the reason that they see it as a risk is not because they couldn't do a software update. The reason is that if something happened to go wrong, they would be faced with a truck roll to thousands of sites and a publicity nightmare. So I guess I would say, well, I wouldn't bet on the meter being much more than a data pump into databases like Green Button or utility databases. I would say, first of all, the answer is it's going to use IP. And if you look over the history of what Zigbee has become, the profiles like Smart Energy Profile, which in the early days of Zigbee were not really considered terribly important, are now really the key technologies that they're bringing to market. And the networking technologies, which were emphasized in the early days of Zigbee, are now really kind of subsumed, as someone mentioned earlier, that the profiles run over all kinds of networks, and the 15.4 networks are now running Internet Protocol. And so the other point I would say about making the whole connectivity story IP is that anytime, industrial, commercial, or otherwise, that you have a gateway between an IP network and a proprietary network, it invites the people that own that to do a truck roll. That's just how it works a lot of times, and people are risk averse to that. Finally, I would say in the commercial environment and industrial environment, especially in commercial, there's a lot of internal communications within commercial organizations that are sharing this kind of information, so it doesn't really pass through utility. If you look at some of the larger big box retailers, they're really setting up their own infrastructure to manage and take advantage of the potential savings through smarter use of energy. And you find other folks like demand response aggregators who are aggregating commercial sites for those that don't have the small and medium-sized ones that don't have the resources to create that kind of infrastructure on their own. I would say, just if I can add one more point, Colin, is that
Sure.
If you look at the consumer market, I would see the cable TV folks and potentially the telecoms being able to segment customers and provide those services, since they're already on premise, potentially more effectively than utilities can. And you're also seeing them start to bundle services. For instance, if a company's providing internet, cable TV, and phone, that's really not a very sticky service. Somebody else, a consumer can churn and switch to another provider, and they'll make it very attractive. On the other hand, if you can bundle in home security or home energy and other kinds of services that are more customized for the home, then that makes the customer stickier, which is certainly an objective those kind of companies have.
Okay, yeah, thanks, Harry. Looking at the broader subject of smart grid network, we are talking here primarily to embedded software developers who are working on various types of device. What kind of application do you think is going to take the lead in enabling the network? Are we talking smart meters, home area networks, or data concentrators? What is the application which is really going to take the lead here? Michael Polk, what do you think? Maybe Itron has a slightly biased perspective here, but I'd be interested in your input.
Yeah, so we definitely want it to be the smart meter. But as you know, Itron also does gas and water, and then, as everybody else has said, all the smart energy profile stuff. We also support, handfuls of that here and there and about. But yeah, going back to what was said about the cable companies and doing the relationships with those, that's been going on forever. I was at a utility in 1990s that they actually own water, power, gas, and the cable company, and they pulled fiber to every home, and they still, here we are, 2013, they still haven't tied that into their metering stuff. So I think it's a big roadblock and a lot of liabilities that are required to make that connection, although it makes the most sense. But I think when you do that, you obviously create a whole bunch of issues. If not, it already be done. And going to commercial and industrial accounts, they have been using phone lines and modems forever. And I think they're now converting, or some of the substations I know about are now converting to T1s, or some of them even going wireless, using cellular backhauls for their internet connectivity. But I do agree with the IP term. But from my standpoint, we definitely want it to be the smart meter. We think that it's cost effective, and that since we're using a publicly owned network, then the utilities infrastructure costs are minimal compared to constructing their own mechanism.
Okay, thank you. Mike Dowell, what's the Freescale perspective on this? What do you see as an application taking the lead on the smart grid network?
I think, again, connecting the consumer via a smart thermostat, like the Nest thermostat, I think is an interesting use case where something boring like a thermostat all of a sudden became exciting, and Nest is also connecting with utilities and offering demand response type services. They have something called rush hour rewards, which they're offering through Southern Cal Edison. These are the kinds of trends I think are going to really push the application in the home for smart energy, and this combination with other verticals like home security are going to drive the market from what we see.
Okay, thank you. And Harry, I'm sure you have something to say on this topic. What do you think is the driver?
Well, I look at the commercial and industrial world, and what happened there was a combination of kind of interesting business practices or business models to essentially drive demand response into the market. And I would look in particular at the demand response aggregators as having done a good job with this. And what their business model was to go to a commercial entity and say, we'll write a deal with you, we'll pay for the installation, we'll limit your demand response participation according to your own needs, and we'll give you a share of the savings. And so that's kind of if you translate that into the consumer market, that's a consumer empowerment story. That was very successful for the demand response aggregators, and what they had to do behind the scenes was manage some very kind of complex trading software and interfaces to the various electric markets. So they had a lot of complexity behind the curtain, but to the consumer entities that they were serving, it looked the interface appeared pretty simple. So to me, that kind of model is probably what would work in the consumer market, albeit it's much more difficult to address that market, and I think somebody will peel off some pieces of it that are desirable, more desirable, and try to serve it that way.
Okay, thank you. The next thing is looking at the drivers for adoption. I received in the mail this week a letter from my electricity supplier who is inviting me to have a smart meter. And they're telling me all the advantages of this, and it won't cost me anything, and why it's a good idea. And by the way, we've got to do it next year anyway in Europe. So it's not like it's really an optional thing from my point of view. But it made me think about, am I in control or are they in control? So who is actually driving the adoption of smart energy in the home? Is it consumers, or is it government, or is it utility companies? Or is it the government making everybody else feel they're in control? I should think, Andrew, you have something to say on this.
Well, who's driving this, I think, is I think it's multifaceted who's driving this. I mean, the reality is that going forward, again, you've got a very lofty goal, and that is meeting the expected demand over the next 10 or 20 years without undue cost burdens on the consumer. So there's an interest in the government, there's an interest in the utility company, and I think for the consumer, the interest is going to be more acute. I mean, if you look at what happened during the Great Recession in 2008 timeframe, I mean, there were literally millions of Americans that were cut off from the utility because they simply couldn't afford it. So and as costs are expected to rise because of the investment in infrastructure that's required going forward, these are only going to be pronounced. You have a large segment of the population that lives on fixed income, and any increase in utility costs come at the expense of something else. So I think it's going to be multifaceted. Right now the consumer is not much of a participant, and largely because I think energy consumption is inelastic, meaning there's not enough information for the consumer to make decisions in real time regarding price and usage. But as more capability comes online, I think that becomes more elastic, and consumers can make choices during peak periods when costs are high to limit their consumption. What's more is I do think there's some low-hanging fruit out there. I mean, when it comes to load control and demand response, certainly empowering utility service providers to turn off your equipment can seem a bit I guess scary, for lack of a better term. But the reality is, take a water heater, for instance. I mean, we don't need the water heater to be on during peak periods, and there's not going to be any risk of not having hot water, as an example. So just empowering a utility service provider to control your water heater could literally save enough to smooth out a peak demand. And you're talking increments that if you can save 1% or 2%, the leverage is staggering. You're talking tens or hundreds of billions of dollars in saving, which transcends into eliminating the need for additional peaker plants or maintaining old systems that are really a large portion of your energy bill today. So Colin, I feel it's going to be multifaceted as far as the drivers.
Okay, thank you, Andrew. I wonder, Michael Polk from Itron, from your perspective, do you think the consumer has any say in this, or is it very much driven by the government and utility companies?
Well, we participated in a pilot where, much like the utility did to you, Colin, where they sent out a flyer and tried to get people motivated about it, and we're going to put a smart meter on the side of their house and give them Zigbee device and provide them with all this information. And then, what they found was that after, a couple of days, the newness wore off and it ended up in a drawer. So I think, and I think the reason why, or at least my opinion, is that our cost of energy right now in the United States, and especially here in Mississippi, is so low compared to what I think Harry was saying, is so low compared to everybody else in the world, that right now it's just an inconvenience. I think as prices and demand rise together, that the customer will ultimately drive the information that they receive. So, some people are doing web portals where they can go in and log in, and they have a link back to their smart meter and then get their real-time usage. So it's, that's a competitor, or if you will, another way of getting the smart energy profile information in a different manner. I mean, everybody has, I'll say everybody, majority of the people that are paying for their own utility bill have a smartphone. So why don't they just log into a website and look at the same information that Itron is providing back to the utility for, for real-time billing information. So I personally think that the consumer is going to have a large part in it, but the only reason they're going to have a large part in it is because the government, the utilities, are going to start driving up the prices, and it's going to cause them to get involved. But right now, we're just, we just kind of got to have it, and we just go with it. I don't worry about what time I turn the dryer on right now. But if it costs me more, and like Harry said, if we go to a demand model for residential, which has been unheard of when we came from electromechanical meters because it was cost prohibitive, but now that we're using electronic meters, it doesn't cost anymore. So now we can do demand on residential customers, and we can give them a penalty if their demand goes too high. And now we've got TOU billing structures. So I think that as the prices go up, the utility is going to change the billing structures, and that the consumer is going to drive getting information about that because they're going to want to understand how that works.
That all makes complete sense to me. And I think the point about the cost of energy being different in different places makes sense, and brings me on to the next question, which is which geographies do we see adoption first? Is it going to be North America, or is it going to be Europe, for example? Harry, I'm sure you have input there.
Yeah, I would favor Europe as an early adopter for some of these, even though they're we've seen a lot of meter activity that probably has reached its peak probably in North America. I don't know. Michael probably knows more about the peak, where the peak might come in that area. But I would say I would bet on Europe because of the high prices, because of the difficulty, and also because right now Europe is really in transition to a much more renewable-based mix of electric generation. Especially Germany is pledged to shut down its nuclear plants by 2020, I think, and is building as fast as their little hands and feet can build offshore wind capacity and transmission capacity to bring new energy sources to their southern industrial. So there's a huge transition in energy going on with high prices to start with. My bet is Europe would be the prime market for this.
That's a very interesting conclusion, and it brings me on to actually a question from our audience, which William Siddall was asking. Is China building smart energy into new infrastructure as they expand? I guess, Harry, maybe you have some input there.
Yeah, the answer is yes. China has a very ambitious plan to do this. It is driven by the need to, as I think I said this before, to allocate scarce resources. China doesn't feel like they can expand their generation at the rate they've historically done it. They certainly can't do that without worsening the pollution problems that they have. So they're trying to shift their primary energy away from coal to solar, photovoltaic, and nuclear, but there's limitations into how much of that can be deployed. So yes, they have a plan. It's part of these 5-year plans that they have there. I'm not sure whether the 5-year plan always takes 5 years or longer. That's really, I'm not an expert on their policies, but yes, they have a plan to really almost register energy users, especially major energy users, and monitor their usage and limit their usage.
Okay, thanks. Andrew, I was wondering, from Mentor's perspective, are we seeing a lot of interest from China in this business area at this time?
Yeah, it's interesting. I mean, so I agree with what Harry just said. I mean, you know, China's the world's largest consumer of electricity, and that demand is only going to increase rapidly. I think over the next 10 years it's supposed to double, and maybe over the next 25 it's supposed to triple. But interestingly enough, the demands that we're seeing are coming from Europe and loosely North America. No real demands from China yet, and that's quite inexplicable. I'm not sure what to make of that.
I guess only time will tell. Since we're in the mode of getting questions from the field here, I've got another one here from Jason Schadenwald asking, how much of a role does software play in making the grid smarter? And what is being done to ensure that software is reliable? It's kind of broad subject, and I guess from Mentor's perspective as a software company, we would say software is absolutely pivotal to making it work. But there's other perspectives as well, I'm sure. Mike Dow, do you have any comment on that?
Yeah, I think what's interesting is that we're seeing from a microcontroller perspective that the software requirements are increasing dramatically, and it's being driven, quite a bit of it's being driven by communication protocols. The higher bandwidth protocols for last mile communication are driving you know, larger flash and RAM requirements. We're also seeing some interest from meter manufacturers in adding value to the metering chips with disaggregation software algorithms. So yes, I think software just in metrology in general, I'm seeing you know, the small 32-bit micros, you know, basically 32K of flash moving up to 2 meg of flash. So yes, software is definitely on the rise. As far as ensuring the quality of that software, I think you know, every company struggles with that. That's the more software you have, the more you have to do testing. The more you make changes, the more likelihood things are going to break. So it's a big challenge.
Thank you. Andrew, I'm sure you have some comment on this. You're a software marketing manager, so.
Well, what I would say is, you know, is we look at the protocols, and I guess in this case, SEP 2.0, there are certainly, you know, lots of software requirements to adhere. So certainly, you know, software is going to play a role for sure. When it comes to security, there are software security features embedded within SEP that have to be adhered to. I mean, that's really an Achilles heel when you look at, you know, what's happening with a smart grid per se, is that, you know, you do open yourself up to sabotage to some degree. So security protocols are going to become more and more important. But also, you know, the network has to be plug and play. It has to be self-healing. The devices, you know, have to be able to introduce themselves on a network in a friendly manner. Allow other devices to understand what services they provide. All the while, they have to understand what other devices are on the network and the services that are provided as well. So you have devices that can act like clients and servers. So that adds, you know, more software complexity. And this is, I'm speaking from a home area network perspective. So yes, this is driving the software requirements, and you know, something that you know, that we plan to meet, you know, within our Nucleus operating system for sure.
Okay, thank you. We are coming towards the end of our session now, but I see Jason's come up with another question, and this is a bit of a left field kind of question, I guess you would phrase that. My American is not as fluent as it might be this afternoon. I'll read you his question, and then we can figure out who might have an answer to it. He says, is nuclear energy really that dangerous in the context of well-implemented modern safety standards? Or is this an irrational public fear that is driving reactionary and ill-advised nuclear energy stagnancy and decommissioning? And I suppose that's in the light of a number of nuclear accidents around the world. There's the one in Japan, and there's been historically in both the United States and in Russia. We can name all of these disasters that have made the headlines, but I wonder if any nuclear disaster makes the headline, and that's why that's got that high profile. Bringing it back to the topic of smart energy, of course, is the smart energy approach going to actually make these things safer, make them more attractive? I would think yes, but there's probably some discussion worthiness here. Harry, you have something to say here.
Yeah, I would say they do. I would say that the plants definitely can be safe, and I don't want to really take this off into a discussion of that particular point. But regardless, with regard to the driver of smart energy, I don't think we'll be in a situation of energy abundance, regardless of what happens with nuclear, simply because the world doesn't have the capacity to build the number of nuclear plants that would have to be built to provide a real abundance of electricity, especially in developing markets. And you can see that in China, where the Fukushima accident has affected policy very little. Yet, because their energy growth is so high, they can't just transition to nuclear. They can't build enough plants to absorb the growth in energy that they're seeing. They have to build nuclear, they have to build coal, they have to build solar, photovoltaic, and other types of plants. And they'd like to build all renewable or nuclear, but they can't do it. So what I would say, Colin, is that we're going to have a mix, and utilities like that, but we're definitely going to have a mix, and I think regardless, we won't enter an era of energy abundance just by changing policy.
Yeah, that makes sense. It reminds me of a book I read some years ago talking about nuclear energy. It was written back in the 60s, and everybody was optimistic. And it said in there very clearly that by the 1970s, metering of power would no longer be necessary because there'd be so much of it available so cheaply. And we wouldn't be having this discussion if that was true, I suppose. But the world has moved on a little. I think we have time for basically one last question, which is actually quite simple. And again, I invite the panelists to pitch in if they have specific knowledge. And that is, Bhupesh Rawal asks, we've heard about China. What about India? Do they have a plan like China? India is possibly the fastest growing country in the world in terms of population, and certainly is progressing technically extremely fast, so energy must be a big thing for them, and I'm sure the smart grid must be relevant to them. Does anybody have any input on India? And I'll put Andrew on the spot first of all, but if anybody else has any input, just let me know.
Actually, unfortunately, I would have to defer this question. I don't have any visibility into India, so I would put Harry on the spot.
Okay, I'll go with that one too. India is, I would answer, they probably have many plans, but the challenge there is availability and allocation. In India, if you look at the IT sector, a lot of the IT sector that has prospered and in that area really builds their own infrastructure. We see the same thing in manufacturing. When you build a new plant, if you build an automotive plant in India and you really want to have power 24/7, then you have to provide your own power plant of some type. So there's a challenge there. I would say their plan is less well developed, certainly, than China by quite a bit. There have been plans to address the supply side issues in India. My assessment, not with a great deal of knowledge, is that those plans haven't really come to fruition. The private sector is still taking the lead and kind of serving their own needs, from large industrial operations like refineries and chemical plants right down to a retailer who has to deal with a daily blackout, and they deal with it using a Honda generator.
Well, thank you. Having worked in India myself, I'm very aware of the blackout situation there. And unfortunately, we're just about to come to a blackout ourselves. We've come to the end of our time. I'd certainly like to thank everybody on the panel today. And I'm going to hand back to Mac Bereshonsky now, who will shut down the session and tell us what's going to happen next. Matt, over to you.
You bet. Thank you very much, Colin. Also, thanks to Andrew, Harry, Mike, and Michael for joining on the panel. This was a great discussion. So thanks also to the folks who are viewing this on our event page. The on-demand version of this video will be available on the same event page that you're viewing this feed on now, and will be available for you to view anytime. If you have any additional Q&A questions, feel free to type them in the ongoing chat below the video, and we will be back in the next couple of days to review any questions and answer any outstanding questions there. So you can see this video additionally on mentor.com/embedded in the next couple of days. So thanks everyone for joining. If there aren't any other remarks, we will sign off, and we will see you next time. So thanks very much, everyone.
Thank you.
Thanks.
Thank you, Matt.
Bye.
So long.
Bye.